So let's start. Last week I've been reviewing Ronan's change to extract the scrub-related logic into an individual queue, so it can be reused by Crimson, and also address a couple regressions introduced by the refractory, which try to adapt the new alien submit to API in the recent SeaStore change. And I think that's me. Aaron.
Oh, hi. I was working on the SeaStore patch, or from the version 3 of SeaStore patch for adding IOCTL and F control interfaces to SeaStore. So the version 3 has been submitted. Maybe no comments yet. So that was update from me. I just
still pending on the upstream's review, right?
Yes. Version 3 is pending. Yeah.
Thank you. Aaron.
Not upstreamed yet. Yeah. I just shared the link. Yeah.
Okay. Chinmay.
Yeah. Last week I reviewed some PRs and provided the SeaStore legacy metrics support. And when I do the testing, I got an alert in ABA tree, but it's only once. I can't reproduce it. It's reported the parent has been invalidated. Not invalidated. Alert happened, but I can't reproduce. I tried several times, and so although the tree still has not used interruptible features, and also reported the confliction for the extent. So I will work on the to convert the tree to use interruptible feature. That's all.
Greg, anything you want to share with us? Okay, probably next time. Redek.
Hello. Okay, let's start from the background. Last week, a bunch of fixes have been merged, targeting the problem about seeing Emily's events in stray and reset states. Here is the gist that describes the investigation. PRs, well, I won't be looking at them. There were a few. Basically, the problem there were multiple problems around OSD activation. In many situations, we started crunching peering events in the booting state. Well, after fixing that, no more problems like Emily's. However, it invited another one that looks like some misunderstanding, basically, between the peering and messenger components. It's basically it's from the log. I think it could be a misdirection of the PG notify second message. Looks like the peering state was wanted to send the message to one OSD, but messenger somehow sent it to another. Just pasted a link to the gist. The problem with that is, unfortunately, the problem is very, very hard to replicate. I'm still trying, but in not waste time in background, I started working on other things. First one is about some optimizations for buffer list SeaStore. That was an inefficiency of SeaStore. Unnecessary rebuilds have been spotted during decoding of the message of the protocol header, basically because of having the empty carriage buffer pointer at the end. I tweaked buffer list to account for that. Another thing I'm working on right now is the profiling of Crimson. Here is a link to the gist. Well, with SeaStore, we look pretty good when using in 4K random reads, when using two instances of Rados bench, sending requests to single OSD with almost empty SeaStore. We are seeing around 35,000 of cycles per operation. I'm continuing. This is because of my last week talk with Mark Nelson, who is testing with Bluster, and I were very curious how it would look like if we use AlienStore with Bluster, but the Bluster with very small, tiny, almost empty content inside. Idea is to expose idea is to not focus on the object store part. It's about exposing the layers of OSD, the components we rewrote with SeaStore, and I'm seeing an extremely interesting pattern. Okay, in classical OSD, if I switch in classical, if I focus on OSD and switch from almost empty memster to almost empty Bluster, basically there is no harm. Similar efficiency is preserved. However, that's absolutely not the case for Crimson OSD. SeaStore to almost empty Bluster with the AlienStore adapter. Hit is around 2 times. Instead of 35,000 of cycles per op, I started seeing 77 thousands of cycles per operation, and the store was almost empty. Profiling, well, there is huge impact of the semaphore plus event FD. Not sure it's everything. Perhaps, well, I'm speculating. In profiling, I'm seeing direct costs of the syscalls, but maybe there are also indirect costs like trashing CPU caches, because also the IPC was instruction per cycle metric has been severely hit. In SeaStore configuration, Crimson does something around 1.5 instruction per cycle, which is pretty good because classical does around 0.7, something like that. So we are 2 times better utilizing CPU. But when using AlienStore, well, the IPC drops to somewhere around 1. In other words, still sniffing hopefully we'll know more today. That's me.
Radek, regarding the observation on the cost introduced by semaphore, do you mean the semaphore introduced by me in recent shardless performance improvement?
Yeah, but it's not only about semaphore. There is also overhead from event FD.
Event FD. How does it kick in? I'm not sure where we are using FD, which is different from the classical SD.
Me too. Man, anyway, my idea is to I want to tweak. I want to compare Memster to Memster. Idea is to tweak AlienStore to host not only BlueStore but also Memster. So I could compare CyanStore, I mean vanilla tiny object store implementation with this almost the same store, but through the exposed through the alien component, alien store component. That would hopefully that would allow to judge the real overhead and that is being imposed by alien store.
Just a side note regarding the overhead introduced by Semaphore. I did some investigation last night after reading Mark Nelson's comments. I realized that we could use a spin lock based implementation to implement the semaphore. Actually, that's what we have if we were using C++20. But that would imply a lot of work to port it to C++17.
But in common we do have a bunch of we have implementation of Spinlock, and we were optimizing it, but I'm not sure we merged the patches. There were a bunch of them. I will take a look on that, because if you're doing a busy wait on your own, you want to take care about things like pausing CPU, etc., etc. Yes. There is a lot of complexity related to that.
Is this really worth the trouble?
I will post.
How much do we care about the performance of AlienStore?
Okay, Sam, I'm looking at the. Sorry, I need to restart SSH. I will post. I will as a comment to the gist. I will post paste from perf report. But from memory, I can say that.
How much of a difference in throughput are we talking about here? Total.
2 times.
It's 2 times slower because of this one semaphore?
Not sure. That's still under profiling. The overall difference between
comment out. I mean, you can test it with and without it. Just comment it out.
Sorry?
Test it with and without it. Comment it out.
Nah, not yet. Just
like that'll tell you the exact number. You don't
because I haven't time.
Oh, I see. You just don't have time.
Yeah, it's work in progress.
Okay, that's at the moment. I just meant that that'll give you a more direct answer than profiling. That's all.
Of course.
Yeah. Or you could just comment out my semaphore based implementation and just revert it to see how it helps.
Yeah. See, what I'm saying is, if the difference isn't huge, or honestly, even if it is that really our priority right now? Like, if we wait long enough, we may get the C++20 implementation anyway.
Yeah, but there is one problem. Mark is going to prepare some slides for management about the efficiency of Crimson, and he does that basing on the AlienStore with BlueStore. And at the moment on the slides we are maybe 25-30% better than classical. And Mark's complains it's not enough. So I'm trying to point out that this kind of
it'll
testing
be far lower with an actually loaded BlueStore, right?
Yes, because even because of Amdahl's law.
Because BlueStore itself is not fast. Yes.
Exactly. I think I speculate. I bet that in real workloads, the object store, the BlueStore will take most of the cycles being burned by entire OSD.
Yeah. So my point is that the fictional value being reported to management isn't fictional enough, isn't a very good reason to spend time on things.
Okay, but this would this requires a convincing mark.
That's fine. Point Mark at me.
Okay.
I'll email Mark.
Anyway, I'm curious. I'm still curious whether the semaphore can explain entirely the results. And
that is worth finding out.
Yeah, it's very quick. So
Thank you, Radek. We'll see. Anything else from you?
nope, thanks.
Okay, Ronan.
Hi. First, regarding the conversation we just had, just some material one you might want to take a look at. This is a book, a performance book, that a guy named Paul McKenney wrote. Is performance in S&P issues for many years. He was working for IBM. I think now he's in Intel, but he's the guy who worked for 20 years to get RCU into the Linux kernel. He pretty much knows what he's talking about. So this is a book that summarizes performance issues, performance techniques in parallel programming, and he has.
I think we understand. Go ahead.
Yeah, I know we know that, but some numbers that what he has at least for example, take a look at this page later on. He has lectures with numbers of that were measured times of various operations like taking a semaphore, spin locking, some discussions of this, which is pretty nice. I know we all know basically we all know everything, but it's good to see the numbers and being reminded of some of the considerations. And he's pretty much an expert, one of the best experts in the field now. Apart from that, didn't do much in the last week on code actually for doing something other things, but I'm still working on scrubbing. I have a bug in the backend refactoring, which I'm trying with one of the counters, which I'm trying to solve, and I have introduced a bug into the scheduling. Somewhere during the latest fixes, I introduced a bug there, and I'm trying to solve that too. Things crash now. That's it for me.
Thank you for sharing, Ronan. Sam?
Yep, I am doing some refactoring to the LBAP tree, use more of an iterator-based approach that will hopefully eliminate the find total insertion bug that May has been running into, and will make some later improvements for supporting clone easier. That's it.
Sam, sorry, I missed your last words. Eliminate what bug?
There's a bug in the LBA manager where when you insert an extent, the place it tries to insert it in the tree is incorrect after split because of a bug in the way find tool works. It's just not correct. So I'm refactoring it to fix that.
Okay.
It's probably the cause for most of Chunmei's crashes.
Xuanhan.
This week I modified the extend placement manager PR and repushed it. I also added the extend scan mechanism for the extend placement manager. It is all in the PR right now, and I think it's ready for review. I'm also working on adding multi-device support into SeaStore right now. That's all for me. Sorry, I can't hear you.
Sorry, I forgot to unmute myself. I recall that we have an offline discussion on Muon's work. I think you might have might be confused on the scope of his work or the target device of his work.
Sorry, I don't quite follow you.
Okay, probably we could discuss later, right after the Yingxing's update.
Okay.
Yingxing?
Last week I added metrics at the cache layer, and I'm trying to review the extend placement manager design, which seems has impacts on many SeaStore components. So I think it might worth Sam to also look at it. That's all for me.
Sorry, to look at what?
The extend placement manager, I think it has
yes.
impacts on many other SeaStore components.
Yep.
Yeah.
I just recall that the offline discussion was the Yingxing. So you mentioned that you're not quite sure about the target device of Muon's rhythm device work. Is that true? Like you're not sure what the exact device is changed.
I guess it was the same device that doesn't need to trim or is not segmented. That's my guess. So.
Then is that correct?
Sorry, what's that?
Yingxing, Yingxing.
Yeah, according to my understanding about the random block manager, RBM, I think this is the kind of device that doesn't need a segmented trim so that it can have the same performance when writing blocks randomly.
Yes, that's correct.
Yeah, so that's.
I still wanted to go through the extent placement manager, and the way the transactions should support it is very much like the out of line events that Xuehan's been adding. But other than that, you're right. It doesn't need to be cleaned. It doesn't have segments as such.
So it's more like a generic SSD device, right? Or RAM PMM.
Yeah, more like Optane devices.
Okay.
Some SSDs maybe, it depends. That will depend on whether it's more efficient to treat those as being segmented or not, because they may be, their internal garbage collection may be so slow that it's more efficient to write to them sequentially. But that's just a call we'll make after benchmarking and measurement.
Makes sense to me. Anything else?
But of course, we would still need the write-ahead journaling portion prior to direct mutation being sent, right?
Sorry?
We would still need to do a write-ahead to the journal prior to mutation. So that portion of the transaction hasn't been created yet.
Mm-hmm.
Anything else? Otherwise, I will update the EasyPad right after the meeting. Nope.
Oh,
Okay,
sorry,
Dr. Rader. Sorry.
I forgotten. Sorry, I unmuted myself too late. Okay, I posted comment with the pastes from Perf report, and it in AlienStore at the AlienStore site. Sorry, at the Alien threads site as well as the Reactor site. However, I'm not sure it's solely because of the semaphore. I think that even half year ago, even basically since the beginning of Mark's testing, we were seeing pretty nasty performance of Bluester. The question is, it could be attributed to the Amdahl slope, and how much efficiency. But from the gist from the comment is rather visible that the effort, the work on conveying the on conveying the requests is pretty large in comparison to real work, real number of to real work performed or actually doing Bluester things. Just compare the Bluester read and Bluester get ATTRs, which is 6.6 and 2.2 respectively, with the entire with actually the fact that the loop, the thread pool loop, takes around 30%, 25, around 30% of all cycles burned by the entire process.
By looking at the performance test, the result, like 8% of time was used by a semaphore wait slow, which happens when
Kifu, it's not time. It's about cycles.
Cycles.
Yeah. So be aware especially if you compare with the results from Mark's GDB PMP, which is about profiling in
wartime.
war clock time. Yeah, exactly.
So I think the reason might be that we are not sending the request fast enough. So the alien threads actually goes into the slow path because it cannot get the message fast enough using the futex. So it's jumping right into the kernel and be was swapped out.
Well, perhaps another factor could be that in case of SeaStore, all the requests all the futures actually are returned fulfilled. There is lesser need to go through the reactor, but well, I'm just speculating.
Wait a minute, if it's just the semaphore, we're just using that to bound the size of the queue, right? Am I remembering this correctly?
I think so. We're using bound size of queue.
Does it need to be bounded? I mean, we do kind of want to push back, but now it does need to be bounded. So what's happening is what's happening that Wait, why is this even coming into play? How much parallelism is there in this test?
It's profiled under two instances of radius bench doing 4K random reads over the cluster instance. There is very little amount of data there.
What was the total parallelism? How many reads
Sorry?
do you expect to be outstanding at once?
Somewhere close to the SeaStore results.
No, just how many reads does the test keep out at once? Can't hear you. What? I can't hear Radek. Can you?
Going through the profile through the.
No, I'm just asking about the test construction itself, not the results. It looks to me like it's two random reads or two Rados bench instances, which are both sending queue size 1, right? This is fully sequential? Or two fully serial reads?
They were random, but okay, they were intended. Let me paste. I'm going
to paste the command in here.
At the exact comment I used to collect data to record the stuff. Okay, updating the comment.
Well, I'm reading the command you put in at the very top.
Sure.
You ran two instances of this bench command, right?
Exactly. Okay, updated the comment. They were two Rados bench instances doing 30-second random read over single OSD instance.
But also, so total parallelism is 2, right? There should be 2 reads out at a time.
That's a question. Also, I think that the queue size for each.
No. The Rados bench instance with this configuration, if I'm remembering correctly, sends 1 read, waits for it to come back, then sends another read, right?
I doubt. I think it sends up to 16 requests in parallel.
So the default is 16?
Yeah. And
okay, parallelism is 32.
With 2 Rados benches, it will.
Parallelism is 32.
That's
okay,
the number.
Great. Okay, so parallelism here is 32, which means we can't possibly be hitting the semaphore limit here. Right? Even if all 32 reads wound up in the queue at once, that wouldn't be enough to hit the limit. Right, Keithu? I remember seeing a much larger number.
What's the number? What's the limit there?
Yes, the size of the queue is 128. So it depends on if we hit the limit of the queue size, and actually there.
It means we're not hitting the limit. 128 is bigger than 32. Unless we have evidence that that's happening, I don't believe it.
But
so sem wait happens, by the way, when the queue is empty, right?
Let me check if the queue is bounded, because the localist queue can be enlarged when the queue size is the default size of the
Yes,
of a
but you
queue.
set up the way the semaphore works to make sure that that won't happen. We always take from the semaphore prior to submitting to the queue, right?
Yes.
So what's happening here is the semaphore is being used to inform the consumer of how many things there are in the queue. So the only reason sem wait would happen is if the queue were empty, which
Yes,
means 32 wasn't enough parallelism to keep the OSD running the whole time. Which
yes,
sounds
that's
right.
why
The
it's
latency
waiting.
is way lower. So the Crimson OSD is going to spend, and more importantly, the Alien Store part is going to spend most of its time waiting, not doing I/O.
So I'm wondering if
Right,
we
Radek?
could put more load on the OSD.
I think so.
So more than likely what's going on is that sleeping at all costs us latency. Because every time we go to sleep, we have to then wake the thread back up to do work.
Well, we could just limit
No, I
the
don't.
number.
What I'm saying is I'm not sure I care about this test.
I see.
This is really artificial. What you're essentially doing is you're measuring the wake-up time for an idle OSD.
We can verify this hypothesis just by lowering the number and seeing whether
Lowering
it's
what number?
the queue size,
No,
the maximum number.
you're not hitting the max. The max is irrelevant here.
But you could test it.
The
You
problem
can
is that
verify your
32
theory by enlarging the size of queue. But I don't think it matters.
No, you can't. It won't make any difference at all.
Yeah, that's my
Because the problem isn't that the queue is too full. The problem is that the queue is empty most of the time.
Oh, okay, I see.
Yeah.
So what's happening is
Okay.
Alien Store is waiting for work. That's why it's going into the SEM slow path. It's because it's literally going to sleep. That's what it's supposed to do. The semaphore is 0. So you wait. That's how semaphores work. That's also how producer-consumer queues work. When the consumer has no work to do, it's not supposed to consume CPU time. So if you did measure performance impact, my guess is that what you're measuring is the increase in latency associated with waking back up when the work actually shows up. What was the implementation before, by the way? How did we go to sleep? Like before we added the semaphore? There was just like an atomic variable, or did it busy wait?
No, we don't do the busy wait. Before that, we were using way before that we were using a single queue, but Xuehan was added the sharded work queue, so to improve the parallelism. And after that, I believe that the lock is too time consuming, so I don't really want to lock to exist in the in SeaStore threads. I mean mutex, POSIX mutex. So I trade it with semaphore in hopes that it would be faster by removing the mutex.
So are you comparing performance between?
No.
What's the performance? No, hang on. Just let me finish. What's the performance comparison here then? What are we comparing against? Radek? You get why I'm asking, right?
Alien Store with we are comparing the following setup.
But not
Alien
a prior
Store.
version. Not a prior version without the semaphore. Okay, so the problem is that any version of Crimson that has ever existed with Alien Store has had this behavior.
Yep.
We've never allowed Alien Store to busy wait. So whether we were using pthread mutex to wake up or whatever, doesn't really matter. I will point out, however, that the sharded work queue concept will make this problem worse, not better.
Yeah.
We actually observed this in classic OSD. You may recall back in the day when sharded work queue was originally added. For OSDs that were frequently idle, sharded work queue increased latency because the individual worker queues had to go to sleep. So not only do we only have 32 parallel requests in flight, we're partitioning them among how many queues
Yes.
by default?
I'm looking into the default number. Threads. Almost there. Just a sec. Oh, it's 6.
Sorry, you said 6?
Yes. 6.
Yeah, so I think that's what's going on. So if we want to test this for real, you should be looking to saturate the OSD. 32 is not remotely enough.
Okay, the
At
point
least
will
I
be
don't think
that
it is.
we won't be able to do to saturate because the reactor part will saturate sooner.
I see. In that case, what you've basically demonstrated is that it's impossible for the alien queue to be a throughput limiter.
Yep.
So we should remove the sharding.
Remove the sharding?
Yeah, so the reason for sharding is to increase throughput, but sharding always costs latency. So what we've done is we traded latency for throughput we can't use.
But by
Still,
removing the
we do
sharding, it's
the
not a pure
M2N
win.
on our roadmap, so sharding will be used.
Wait a minute. What I mean is we should make the default 1 right now.
Yeah.
In the future, we may need it if there are multiple cores, but I'm telling you that the total number of alien work queues to core will be somewhat south of 1. So it might be we need 2 Crimson cores per alien store queue.
1 will be too small. Okay, now I recall. I've introduced that variable, and I did that because 1 was not enough. I believe there is a guess. I need to dig, but there is a guess comparing multiple values. However, it was before introduction of sharding.
You're saying you're looking for a regression that happened before sharding? Is that what you said?
Sorry, could you repeat, please?
You're looking for a performance regression that happened before sharding?
Yeah, I think so.
Is it big? Because we expect performance regressions. We're adding code. For instance, if interruptible future caused a regression, it did so by fixing a bug. The old code was wrong.
I see. It's essential complexity, and you really want it no other way.
Well, no, there is another way. Like, we will eventually need to start pressing these things down. It's just that performance investigations like this are super expensive.
Okay, I found the gist.
By the way, Shahan, do you recall that what's the test you performed when you were testing the sharded queue?
I didn't do random read. What I did, it was random write. It's
Random write.
about
Oh, okay.
it's about 15,000 IOPS, if I recall it correctly.
Were you using the Redis bench or some other test, some other tool?
No, I was using FIO and with
Okay.
RBD image.
Oh.
So that's the other thing. Rados Bench is kind of terrible at this, which is why I was asking about total number of reads. RBD or FIO is going to be able to generate more concurrent reads than Rados Bench will. Well, given the same.
Well, Rados Bench also, but we would need to bump up a proper parameter. It's controllable.
No, I know, but FIO you can actually do things like control the distribution of reads over the device. It's just a better tool.
Okay.
Like Rados Bench is fine, but it's a really coarse tool. It's also surprisingly client limited in a lot of situations.
Yeah.
So you actually did see a performance advantage up to 4 threads. Interesting. What was the workload in this one?
4K random
Looks
reads.
like Rados Bench again.
Yeah, yes.
This was with looking for the command. Also with the default 16 threads?
Yep.
And just 2 of them. Okay.
But we were using write by then.
No, this is still read. Same deal. So this is the same test, as far as I can tell.
Very likely so. I think so. Yep.
I mean, I'm looking at the command you ran. The same one. So wait, start me back at the beginning. So this semaphore problem you're tracking down, this is you're just comparing you're just looking at the perf dump of this run. You're not comparing it to any previous commit. Okay, so this isn't a regression. You're just interested in what's taking a lot of time here.
Exactly.
Okay.
Because my main focus is not even on regression we have or not in AlienStore. I'm curious why introducing AlienStore lowers the cycles per op so much, 2 times. So it's not about 8%, 20%. It's 2 times slower. Less efficient.
What are you doing with the BlueStore core threads? Are you letting them schedule anywhere, or are you trying to force them somewhere?
Not sure. I'm using defaults.
So it might be worth making sure that they never get scheduled on the same core as the Crimson reactor itself.
Yeah, yep.
I mean, that's the most obvious reason, right?
But I think we already pinned them in default configuration to different CPUs.
From each other, yeah, but I'm not sure because I know when you
one OSD.
I'm sorry.
One single OSD.
I know.
There is only one single OSD in the testing, so sharing.
That's not what I'm saying. I'm saying I think the 0 thread for BlueStore might map to the same core as the SeaStore reactor. There are some situations where we do that on purpose. So that might be worth checking.
I think the default setting is pin BlueStore threads to the last 5 or 10 CPU cores.
Okay, so it'll never be?
I think that's not the SeaStore thread. Well, that's not the CPU core that SeaStore threads are running.
Got it.
Where are we? I think we should use FIO and to put more loads on the single OSD to ensure that the alien store does not do the slow wait. Am I right?
Well, so the other thing is, if this is time wasted on a thread that isn't actually a blocker, then I kind of don't care. So remind me of the structure here. We have thread pools responsible for submitting to BlueStore, right?
Yes.
So Radek, riddle me this: is this thread pool actually relevant?
Sorry, I was. Could you repeat, please? I missed the part.
Oh well, no, it is. Never mind.
Per stump, the semaphore wait actually takes cycles.
Yeah, I know, I'm looking. Well, we sort of expect it to, right? Every time you go to sleep, you need to do the thread itself needs to do some cleanup, then it, calls back into the kernel, which puts it to sleep. Upon wake up, it has some restoration work to do before it finally gets, back to.
Yes, and those are only the direct costs of the operations. They are also
Wait. So what I'm saying is, the process of going to sleep costs CPU cycles, but the fact that we went to sleep means that we didn't have anything better to do. Do you see what I mean?
So it costs more CPU cycles because it is relatively free.
Yes, exactly. And it's not that it costs more CPU cycles. It's that a larger percentage of the CPU cycles that it spent not sleeping were spent going to sleep. But that doesn't mean that most of the time was spent that way. You see what I mean? So in other words, if the thread actually spends 50% of its time sleeping, just literally not scheduled at all, and then of the remaining time, 5% is spent going to sleep and coming back, or 8% here, and the remaining 40% is spent doing real work, then in this performance graph, we'd see 5% over 50% as its CPU cycle spent in SEM weight, but it would still be almost completely underutilized. The only reason SEM weight would seem to be taking up so much time is because it was mostly idle. Like what perf tells you is percentage. It samples cores at different times, attributes those things to threads, and then gives you the ratio of samples that happened in each bit of the call stack to the total set of samples. But it doesn't take any samples when the thread's asleep.
And it counts globally. It counts every single thread of the process into the denominator.
Is that actually
calculating
true? Because if I'm looking at this, it looks like it's only considering things that happened as subcalls under Crimson OS thread pool loop. So I don't think that's
well.
True.
It's because I filtered it at the level of perf report. However,
right, but that means that this 8% is relative to that call graph, not relative to the whole program.
Whole program, I'm pretty sure. I just filtered the view, not the data being used to do the math. In other words, 27% spent in the loop is about in comparison to the all cycles recorded, which means all threads from the entire process. I was just take a look on the perf record.
That might actually be right.
There is T instead of T. So
27% of the samples are from the alien thread pool thread itself.
Right? Exactly.
So if both threads were running the whole time, that would be 50%.
Is there a possibility that the SeaStore thread just can't keep the queue full because it's running on only one core?
No, I think we're latency limited. I think that, yeah, I think we're latency limited here. Either it's the case that the Crimson reactor, that the SeaStore reactor is, as you pointed out, saturated, and it can't keep BlueStore full, or neither is saturated because 32 concurrent reads wasn't enough. Either way, I don't think this thread pool thread is saturated. I think it's sleeping about half the time.
I agree that the alien part looks unsaturated.
So for that reason, I really don't care about the stem weight example. That's just an artifact of a thread without enough work to do.
Agreed. The question is whether the SeaStore, the reactor part, is able to saturate the sharded alien star.
I mean, you've essentially set things up so that it can't, right? If I understand the construction of this test correctly, there's no data in BlueStore, so everything fits in cache, right?
Yep.
So you've basically set things up so that we will do more work in the Crimson reactor than we will do in Alien Store. So I'd say
Exactly. The idea is to
successful. Like, this is what that looks like. I think, right?
The
Yep.
bottleneck is only is in the SeaStore side.
Well,
Instead
not
of on
necessarily.
alien
It could be the client. We haven't actually proven that the SeaStore part is saturated either. But whatever it is, it's not this Alien Store thread.
So probably a better test is to use FIO and with a larger depth, IO depth.
I think we can print out the semaphore value to verify whether which number it is.
Well, it's sem weight, so it almost, and given the 32 parallelism, it basically has to be the case where it's empty. Feel free to print it out, though.
Yeah.
But again, I think this is exactly what you'd expect to see with the setup you've created. I think this is normal behavior.
I recall that when I was testing the Alien Store, I compared it with the classical SD and with the same BlueStore threads, and the classical SD is about 30%. The IOPS of the classical SD is about 30% higher, and at the time, the SeaStore thread is fully using the CPU core that is running on. So at the time, I think it was the SeaStore thread that was the bottleneck for the whole testing.
Okay, so you had saturation. Have you checked the Sykes per op?
No, I didn't do that.
Okay.
I'm confused. If the SeaStore thread is saturated, why did you try to increase the parallelism by adding more threads on the alien side?
I didn't increase the Alien Store threads number for better performance. I just want to compare it with the classical SD. So I just set the Alien Store threads number to the same as the BlueStore Alien Store, and then I run the test. And once I found out that the SeaStore thread was the bottleneck, I didn't do any more tests. So I don't know if I'm making myself clear.
By shorting the queue, you have a better performance than
Oh no,
before.
actually I just thought because sooner or later we will run Crimson OSD on multiple cores, so I think it would be better to have the hidden store work queue sharded.
So your improvement is not supported by performance tests, right? Am I understanding
Yeah.
correctly?
Yes. Yes. Yes.
Okay, so there's a chance. In other words, there's a chance that before you change, we might have better performance with a single queue,
Uh,
with a
I
single core setting
uh,
on the alien side.
that's possible, but I think that possibility is not supported by Radix test because uh, the test shows that the same weight has more CPU cycles because it is relatively free. So
So by adding more thread
Yeah,
in the thread pool
guys,
actually helps.
the test is constructed with the Cyan and Memster in mind. Using it to bluster is well is just an incident.
okay. I still think if oh sorry
So
I
with
don't
Memstar, the performance of Crimson is better. So I don't think with Alien Store that suddenly SeaStore becomes a bottleneck.
Well, it looks to me that Alien Star hurts not hurts the IPC ratio of entire process. In other words, it hurts the performance of reactor itself.
Yeah, by submitting the request from the SeaStore core to BlueStar core, right? So that process is hurting
Exactly.
performance.
The
I
overall
think if
cycles per op goes down by factor of 2. The same with IPC.
so the performance degradation we're talking about is in terms of IPC, right? Not
Exactly.
the
I
total
think
IOPS.
the main reason is because not only because of doing more work, like conveying the stuff between multiple threads, it also because of lowering the efficiency of of. Well, I haven't put
I'm
the
not
number into
sure.
the GIST yet, but just to recall, when using SeaStore, Crimson is able to hit around 1.5 instruction per second. With BlueStore plus AlienStore, it goes down to maybe 1 instruction per second, which perhaps could be explained by the indirect costs of let's say, semaphore waiting. But it's just a speculation.
Can you get per thread cycles per instructions per cycle information, or per core? I
Yeah,
asked
we
because the
can
answer may simply be
make
that
sense.
Blue
Yes,
Store's
we can do
internal.
that.
Yeah, have a look at that. If the
Yep,
answer
yep,
might
yep, yep, yep.
fairly boringly be that Blue Store's efficiency is just a lot lower. So when you add that to the average, well, it changes.
That is also a possibility. But we can it could be judged pretty easily. Perfstat has option to profile a specific thread only.
Yeah, I think we can also try to reverse the shadow queue change to see if it helps with the performance actually, because there's like six threads in this picture. They are trying to swap in and swap out when there's a job in the queue, when there's not, and when there's not. So a single thread might help if the load is not enough to saturate the sharded queue.
I have a question about the best practice to do performance test. So I think if we use FIO with librd, is it also mean that we have a much longer IO path that we need to first go through librd and then to the Crimson? So that's not a good practice. So my question is if we test Crimson performance with librd, does it has a much longer IO path in the RBD part?
You're worried about the impact of client-side librd on the total testing environment?
Yeah.
Not really. If you make sure you put the client in a resource unconstrained place and give it enough total parallelism, I don't see why it would matter. Also,
Yeah,
keep in mind, Rados Bench does almost everything librd does.
Oh,
Rados
okay.
Bench is
exactly.
librd.
On hot path, I think that the Rados bench very closely resembles basically RBD makes some extra like Ceph classes only on cold paths.
Yeah, in either case, the expensive parts of the object are in the messenger, and that's present in both cases.
Okay.
And of course, we're not testing the client, so if we're worried about testing throughput, we can always just use more RBD clients. It's not a big deal. Same is true of Rados Bench, of course.
Yep.
Oh, so, I mean test in the all-in-one environment.
Well, I
If
mean,
I don't have multiple machines to
okay.
You should always be pinning your clients to different cores from the OSD under those conditions.
Mm.
But again, librd isn't really more expensive than Rados Bench.
Okay, I got your point. I got your point.
And everything under assumption you have enough cores to delegate expensive Rados benches. Okay, if you are testing on laptop, that's a constraint. But on any reasonable server, it should be fine.
Anything else? No?
All right, later.
Later. Have a good one. Thank you.
Thank you. See you later. Bye.
See you.
See ya.
Bye.